Okay, before I start going over the notes, I just want to give you guys a reminder, because I'm not there, that your quiz corrections are due on Monday. That'll be the 2 days. You got them back yesterday, and I'm not going to give you a spiral since I'm not here. The few of you who weren't here yesterday, Sarah, JR, Andrew, and Allie, I have your graded quizzes on my desk that hopefully this up can help you with. Okay, so similarly to what we did with ellipses, we're going to look at this format and have to complete the square to get it in the format that we need. So group your x's together. Group your y's together, the minus 9y squared minus 72y, there and there, and then get rid of your 269. Then we're going to, again, before we complete the square, we're going to factor out that 25, and then leave a little gap. And we're going to factor out a negative 9, and that's huge that you realize that that's negative. That's really what tells you that this essentially is going to be a hyperbola as opposed to ellipses, because hyperbolas are negative, ellipses are plus. So when you divide out a negative 9, that negative 72 is going to become positive 8y. Again, leaving a little gap. So half of negative 4 is negative 2, squared is adding 4 in here. But you're adding 4 in a set of parentheses that has a 25 coefficient. So 25 times the 4 means I really added 100 to the left, so I have to add 100 to the right to keep it even. In here, half of 8 is 4. So square 4, you're adding 16. What I really did is I subtracted 9 times 16. So 9 times 16 quickly on your calculators would give you 144. I actually subtracted 144, so I have to subtract 144 on the other side as well. So what this does for me when I factor is it gives me 25, and then this factors into x minus 2 squared, minus 9, and this is y plus 4 squared, equals, and then that's 369 minus 144 is 225. Okay? So just like ellipses, these needed to equal 1. So the format that we looked at yesterday, which was here, they equal 1 also. So we're going to go ahead and divide by 225. And the 225 and the 25 reduces to 1/9. Oh, 25 over 225 is 1/9. Minus, and then this one reduces to 1 over 25. So you've got your parabola format. Okay, so now that we have this, there's a slight difference here from ellipses. In ellipses, A was always our bigger one. In hyperbolas, A is always the one under the positive version. Like, there's no way to flip-flop these. I could divide both sides by -1 and it would flip that order, but then it would equal -1, so that's no good. So A is not always going to be your bigger one in this case. A is going to be underneath the first term. So your A is 3 and your B is 5. So from here we're ready to kind of start our graph. We have a center at 2, -4. So that's in the 4th quadrant, so I'll try to give myself more space in a 4th quadrant. And the center's at 2, -1, 2, 3, 4. And that's the center of like my guiding rectangle that we talked about yesterday. So in the X direction, left, right, I'm pulling 3. So 1, 2, 3 to the right gives me that side of the rectangle. 1, 2, 3 to the left gives me that side of the rectangle. B is pulling in the Y direction, so 5 up. 1, 2, 3, 4, 5 gives me that one. And 1, 2, 3, 4, 5 gives me that one. So if I complete this rectangle, and again, this is not part of my hyperbola graph, it's just a guide. My diagonals, 1, 2, 3, 4, 5 over 1, 2, 3. 1, 2, 3, 4, 5 over 1, 2. I'm going to try to keep this as straight as possible. 1, 2, 3, 4, 5 over 3. Those kind of give me my guide. And then similarly here, that gives me my guide in that direction, and this gives me my guide in that direction. So then as far as sketching the hyperbola, whatever's first, and in this case it's an X, so I'm going to refer to this as an X hyperbola. X hyperbolas open horizontally, which means left and right. So yesterday we saw one, I'll show you quickly, that started with Y. Because it started with Y, it opened up and down. This one starts with X, so it opens left and right. So just going right here, there's a vertice, and it's a pretty wide one at that. And then here's the other vertice on the edge of the rectangle. And again, it's pretty wide because it's got to follow those diagonals as asymptotes. So if I'm listing off the points up here, the center we said was 2, -4. The foci we have not yet found. Now the formula for foci is a squared plus b squared equals c squared. It really does mimic the, I know the foci are going to be here and here somewhere. They're going to be inside the bowl and inside the bowl over here. But I need to find C, their distance from the center. So if the vertices are 3 units away, it should be a little more than 3. So a squared plus b squared equals c squared. I've got 9 plus 25 equals c squared. And that's 34 equals c squared. So c equals root 34. Which is approximately, let's see here, square root of 34, 5.8, which is certainly bigger than 3. So if I go 1, 2, 3, 4, 5.8, there's focus 1. And I go 1, 2, 3, 4, 5.8, there's focus 2. Sorry, it's running into my work. As far as coordinates for that, you're going over 2 initially to get to your center. You're going over 2 down 4. So now we're going to go over 2 still, but an additional root 34, and then down the 4. So your one focal point is 2 plus the root 34, still down -4. And your other one, because you move left, it's where your center started at 2, but you're subtracting the root 34 backwards, and still the same y coordinate. So those are your focal points. Your vertices, we have -1 and then -1, 2, 3, 4. And 1, 2, 3, 4, 5, -1, 2, 3, 4. The length of the latus rectum. The latus rectum is, again, just like in an ellipse. It goes through the focus perpendicular to this main axis. So it's perpendicular to the line that contains the center and the vertices and the focus. And it goes through the focus, and it's pretty wide here. The formula is the same as it was for the ellipse, 2b squared over a. So for the latus rectum, it's still the same, 2b squared over a, which 2 and b squared, if b is 5, b squared is 25, over a is 3. So that's 50 thirds, which is pretty long. 17 units. 16.6 repeating. But that's pretty long, and you could, I mean, we don't have it exact, but we could kind of count and get somewhere around 17 units between all of that. And we're done. That's everything. So we'll do one more, and you can obviously rewatch this video and as many times as you need to make sense of everything. So let's rearrange that. You notice here the y squared is positive, so I'm going to keep that first. 4y squared minus 24y will cover those two terms. Minus x squared minus 4x will cover those two terms, equals negative 16. If I take out a 4, I get y squared minus 6y. Here I'm going to take out a negative 1, and I have x squared plus 4x when I do that. So in here, completing the square, I add 9. Half of negative 6 is negative 3, and negative 3 squared is 9. But I really added 36, so I have to add 36 to counter that. Over here, half of this is 2, so square that number, and I get 4. I really subtracted 4, so I have to subtract 4 to counter that. So when I factor, I get y minus 3 squared and x plus 2 squared equals 16. And then again, needs to equal 1. So divide that 16 everywhere, and everything reduces pretty nicely. So this is over 4. This is over 16, and this is 1. So this is a y hyperbola. It opens up, down. But again, let's go back to our center at 3, negative 2, which again is the fourth quadrant. So I'm going to make the majority of my graph a fourth quadrant. So, oh, I'm sorry, screwed that up. 3 is being paired with the y, so that's the y coordinate of my center. My center is negative 2, positive 3. Got to go x coordinate first. So I'm going to change up the way I did that. Negative 2, positive 3 is second quadrant, so I'm going to go mostly in the second quadrant. Negative 2, positive 3. There's my center. So I have my center. I'm not going to find my focus yet. My vertices, I got to stretch my box to get my my guidelines here. Stretch that rectangle. So in the y direction, we're going up 2 and down 2 from the center. And in the x direction, we're going left and right 4. Drawing those diagonals as a guide. And then again, this hyperbola, because the first term is y, is opening in the y direction. So your first vertex is there on the rectangle edge, because I'm about to go up and down, but again, pretty wide. And your second vertex is down here, pretty wide. So your vertices have coordinates negative 2, 1, and negative 2, 1, 2, 3, 4, 5. And your center obviously was negative 2, 3. Okay, so there's our vertices, and then the foci, again, is going to come from a squared plus b squared equals c squared. A is 2. It's always your first one, so that's 4 plus 16 equals c squared. So c squared is 20, and c, the distance from my center to my focus, is going to be root 20, which is approximately I get the decimal value, approximately 4.5. I get the decimal value so I can estimate it and count it and graph it accurately. I get the radical value so I can give the point accurately. So if I plot it, I'm going up 4.5-ish. 1, 2, 3, 4. There's focus 1. And 1, 2, 3, 4 and a half. Well, I didn't go up to that half. 4.5-ish would be right there. 1, 2, 3, 4 and a half up. But as far as the coordinates for those, they're both at an x-coordinate of -2. That's remaining the same. I'm still going left 2. But for this one, I was at 3 for my center as a y-coordinate. I was at 3, and I'm adding on that root 20. So the y-coordinate is 3 plus root 20. And down here, I was at 3, but I dropped down the root 20. So 3 minus root 20. And there's our focus points. And the last one is the length of the latus rectum. So latus rectum equals 2b squared over a, which b squared is 16 over an a of 2. So again, the a is always the first, comes from the first denominator. It's not always bigger in this case. And b comes from the second denominator. So in ellipses, a is always the bigger of the two. Not true for hyperbolas. A actually just has to come first. So that's 16 is the length of your latus rectum, which is really the distance here. That should be about 16 units long. And then same thing down here, should be about 16 units long. You know, not exact, because I probably should be closer to my hyperbola, or to my diagonal by now, but the general shape is there. And so you have a homework assignment that's going to be handed out. You have 4 questions on it. You are to do all of them. Other than that, corrections and the homework due Monday.